Hi, this is Austin with Progress Report 2. I'm going to go ahead and launch in real quick to show you the AABB actually working properly. So you can see I have the tanks and the enemies set on that, and you can see it change shape as I rotate. I'll change around to here to get a better look. And then, so collision works with AAB against AABB, which is why I died there. Launch again real quick, let myself get hit by the bullet. You can see me take 1 health, and I can kill these guys as well. So that should be everything that needs to be shown visually in terms of that. So I'll go ahead and look at the code real quick. There's a whole lot. I'm not going to go into deep detail on everything, but first, so this is using a volume now, not a specific B-sphere. I also have here the check to determine what kind of model it should generate based on the passed-in volume type. Everything else is the same. Collision volume, I added the extra functions, the accept, visit, and then another one for send collision command, so that the AAB could also send its own command without me having to make 2 separate functions for that. So it has a get min, max, get trans, and scale, and those for all are all vectors, plus the various implementations of all the different special classes. Most of those are one-liners, followed by the check for every point to determine where the min and max are. That's shown here. I just loop through, do a series of checks. And then the send call command just adds the command of the AABB factory, which I'll get to in a moment. Actually, I guess I'll look at that right now, real quick. It's nothing fancy. It's pretty much just the B-sphere factory, but with AABB commands instead. Just creates and recycles, and then the actual command is here. It has a box and a color, and it has functions to actually set those, and that's about all that it really has. So looking at the visualizer now, we have a list of B-spheres and a list of AABBs. Here are all my various show volume, show B-sphere, show AABB, and the private renders for all of those, plus the add commands. The B-sphere show is the same. Show AABB is just, it gets the scale and translation from the AABB, and then the private render just does the set world, set color, and all of that, and then it visualizes both lists separately. And then the math tools. So I did try to keep things separated and compact, so I have my five, not 4 intersects. I have an extra one for intersecting a point with a AABB, a clamp hole point, a test interval overlap. Those are all here. They really shouldn't be too much of a surprise. I mostly just lifted the stuff straight from the 3D geometry slide, so that's all for those. So for this part of the doc, I tried to focus specifically on new systems that I would want to implement based on what I talked about last week. So first of all, a lot of these are going to be, I suspect will probably be sprints, but I'll talk about them anyway. So the terrain generator essentially just takes the black-white pixel map, just like the one we made in graphics. User gets to control the base height, max height, all the same stuff as from there, and it should mostly be a similar, if not the same implementation, although since I'm not using DirectX, there might be some conversion necessary for that. I'm not entirely sure. So yeah, a function that would take 2 points that would represent 2 ends of a line, and using that line it would determine whether or not you're intersecting the terrain, and if so, what face you're intersecting. That way, the tank can shoot like a line below it to determine what face it's on top of, and then snap to that normal. So I would still be using normals for the terrain. And then for the background generator, Skybox, again, pretty much similar to graphics, might require a few changes, no normals. And then, let's see. Yes, it'd be cool, I think, if you could also choose to have a static image background in case you're making like a 2-dimensional game, or for whatever reason you don't want a skybox, and you just want it to be a constant image. I don't know how hard that would be, considering how weird sprites work when you try to draw them before models, but I'm sure there's some way to do that, so I'm going to look into that and see if I can make that feature as well. UI improvements, I think it'd be cool to have a UI manager that could automate some of the processes that I'm doing now, like health bars I mentioned here. You pass in the sprite, a string to label the health bar, and then like the starting position, like where on the screen you want it, that is, and then the amount of space between each sprite. And then you would have separate functions that pass in how many sprites should currently be being displayed. And then I think it'd be cool, I haven't necessarily got this in the demo as it is yet, but to display a title text, like to say, this is what level you're on, and, you know, like how some games do it. That would either just stay there forever, or you could have it pop on screen and then vanish after a certain amount of time. Then there's the particle system. We've talked about this in class before, and I admittedly don't necessarily know that much about implementing one, but I figure that, again, might be part of one of our sprints. And considering that right now things just snap out of existence when they die, I think the particle system would help with that. And then last but not least comes my all the stuff with my personal project, and this one's a lot longer. So I actually have some examples here that aren't necessarily implemented but are supposed to show what the idea would be. So storable type of game object, similar to all the other game object superclasses. You'd have registration, deregistration, and all that. You could store data, and you could recreate an object from that data and load it into a certain scene. Other than that, all that's the same kind of code as in all the other UBLs. So the storable manager is, again, just similar to the other managers. Instead of process elements, it would go through and store all the elements. And the way I'm planning on doing it is just have like this this class that would store some of the important variables. Like right now, I think I have in here. Oh, this is the wrong one. I have in here the store node, the inputables, alarmables as lists. And then I was planning on adding, and I haven't done it yet because I'm not entirely sure I want to do it, but at the very least, you'd need a matrix for the world matrix, a string to determine, or a pointer of some sort or something to determine what kind of object you've got. And then right now I just have one float. There will probably be more of other data that you also need to store. So that's all that. And then another recreate with scene. And then I have the store node manager, which just would have a linked list of store nodes, a first and a last, because you need to insert to the end to make sure that the update order stays the same when you recreate everything. So I have here a store, a recreate scene, which would just go through all the store nodes, call their recreates, and then some serialize and deserialize functions, because on the one hand, I do want this to be usable for like a pause function where you could just store a scene and use it later in game, but I also have found a whole big glossary of stuff about serialization that I could also use to save it in between games. So like if you wanted to save and then reload your progress. And in addition to that, I am also in networking, which we talked about serialization just the other day. So hopefully with all that, I should be able to implement the ability to serialize and deserialize data to a file pretty easily.